All right, this is going to be our first sample problem of mole-to-mole stoichiometry. So in these kinds of problems, your given is a value of moles and your unknown is also a value of moles. So what we first need to do to tackle these questions, we're going to need a balanced equation. So the question says, how many moles of oxygen are produced by the decomposition of 2.8 moles of potassium chlorate? And then we are also told, when heated, potassium chlorate decomposes into potassium chloride and oxygen. Now that's a piece of info that you likely would have if you were being asked a question like this, but you would not have the balanced equation. That is something that you should be able to do at this point in grade 11 chemistry. So potassium chlorate is our reactant, and we know from our first unit together, potassium is K and the chlorate polyatomic ion is ClO3. So that is our reactant. And then it decomposes into potassium chloride and oxygen. We know that potassium chloride is KCl, and we know that oxygen is O2. We know that about oxygen because oxygen is one of the diatomic elements. So our next step here would just be to balance this equation, which I will just quickly do now because we have had some practice before with balancing chemical equations. So what this means when we say 2 KClO3 yields 2 KCl plus 3O2, that's really telling us a molar ratio of this reaction. So this says 2 moles of potassium chlorate yields 2 moles of potassium chloride and 3 moles of oxygen. So for every 2 moles of potassium chlorate that you put into this reaction, the output is going to be 2 moles of potassium chloride and 3 moles of oxygen. And our question asks us how many moles of oxygen are produced by the decomposition of 2.8 moles of potassium chlorate. So the first thing we can do, we could look at this and then by inspection, we would know that there is a 2 to 3 ratio of potassium chlorate to oxygen, which would mean for every 2 moles of potassium chlorate, you get 3 moles of oxygen. And then, you would just know that you would have an equivalent proportion. So you might be able to arrive at the answer of 4.2 moles simply by inspection. But another way that you can always set up these kinds of problems is to simply set up your proportion first. So we know from this reaction that 3 moles of oxygen, there is 3 moles of oxygen produced per every 2 moles of potassium chlorate, right? And that straight line separating the 3 moles O2 and 2 moles KClO3, that is the line separating the numerator and denominator of a fraction, and that line means per. The divide function mathematically means per. So there's 3 moles of oxygen per every 2 moles of potassium chlorate. If we put this into lowest terms, then that becomes 1.5 moles of oxygen per every 1 mole of potassium chlorate. And then we would have just a nice proportion or multiplier that we could use to determine our answer here. So we know at the beginning we had 2.8 moles of potassium chlorate. And that reaction gives us 1.5 moles of oxygen for every 1 mole of potassium chlorate. And then we simply multiply these two values together. keeping in mind that the units in moles of KClO3 are going to cancel out. And that's a way that you can always double check to make sure you set up your proportions correctly. So in the end, 2.8 moles of potassium chlorate. When we multiply this together, we're going to get 4.2 moles of oxygen. And then we can just say, therefore, 4.2 moles of oxygen are produced.